Hello friends, my name is Baji. Welcome to our channel. This is episode number 7 in our performance testing must-have skills series. In this video, we will continue to discuss the remaining server architecture module concept. If you watch this series for the first time, please watch previous videos of this series and continue these concepts. You can find the link to this playlist series in the description. Let's start with the topics covered in this video. First, we will discuss the different things that you should be aware of about the servers. Then, we will discuss different types of environments that companies will have to build the application or software. And then we will discuss the concept of protocol and the different types of network protocols that are available. Then we should quickly look into some of the other components that we generally see in different software architecture patterns. Finally, we will discuss the concept of URL and its different components. So without wasting any time, let's dive into it. Let's explore the various important factors that demand our attention when it comes to servers. When we understand the software architecture pattern, it is equally important to gather comprehensive information about each server available within the architecture. In performance testing, both software and hardware configurations are essential factors that can significantly impact the accuracy, reliability, and validity of the test results. So, we should understand both hardware and software information of different servers that are available in the architecture. First, let's look at the type of hardware information that we should be aware of. CPU stands for Central Processing Unit. Some people also refer to this as the processor. In general, for faster task execution and parallel processing, the teams will choose a CPU with multiple cores and high clock speeds. So, we should understand the type of available CPU architecture, number of cores, clock speed, etc. I intended to stay focused on the context, so I won't dive into the specific details of various underlying CPU concepts in this discussion. If needed, we can have separate videos on these concepts in the future. Next one is memory. Sufficient memory is crucial to prevent bottlenecks. Inadequate memory can lead to swapping and degrading performance. In general, the required memory for a server will be chosen based on the application's requirement, and also they leave additional room for the growth. Sometimes, with poor memory management, the application might be consuming more than required. So, knowing memory details will definitely help us during the performance testing to understand if we have any memory related issues. Next one, storage. The type of storage like SSD, solid state drives, HDD, hard disk drives, and storage capacity and RAID redundant array of independent disk configurations can impact read write speeds and overall system responsiveness. So, we should understand the type of available storage and its capacity and whether we have any RAID configuration setup. For instance, we have different types of RAID configurations such as RAID 0, RAID 1, RAID 5, and RAID 10. Every configuration has different advantages and disadvantages. So, knowing the type of configuration will definitely help us during the troubleshooting sessions. Next one, networking. Network bandwidth, latency, and throughput are vital, especially for web applications that rely on network communications. For example, gigabit or 10 gigabit Ethernet ports are common for servers. The teams will choose the appropriate speed based on the network infrastructure and data transfer requirements. So, we should understand the available network bandwidth information. Ultimately, the hardware configuration should align with the server's intended workload, whether it's web application, database management, or any other specialized task. So, knowing or gathering this information is very important prior to initiating our performance testing activities. Now, let's look at the important software information that we should be aware of. Operating system. An operating system, also called OS, facilitates the interaction between the user and the computer hardware components while offering an environment to manage and control the execution of software applications. The OS can influence how your application performs due to differences in resource management, libraries, and system calls. So we should be aware of the installed operating system. Based on the needs and requirements, companies will use either Red Hat Enterprise Linux or Windows Server operating system for their servers. We should also be aware of the installed OS version, as software companies like Red Hat and Microsoft will continuously release new versions to accommodate new features and fix the existing issues. Just remember that there are many other server operating systems available in the market. Based on the purpose of the server, different softwares will be installed. For example, if it is to handle the business logic, then application server software will be installed on the server. If it is to handle the data, then database server software is installed on the server. So we should be aware of the installed software on the servers. Some of the examples of web server are Apache HTTP Server, Nginx, Microsoft IaaS, Apache Tomcat. Similarly, examples of application server softwares are IBM WebSphere, Oracle WebLogic, JBoss. Database server examples are Oracle, SQL Server, IBM DB2, MySQL, and many more. These are some of the examples of different software, and there are many more. In interviews, they will sometimes ask us to tell the different application or database softwares that we have worked on. Along with the software names, it is very important to understand different versions. There are several reasons why different software versions are created. Some of them are like bug fixes or improvement. That means new versions are released to fix these problems and improve the software's stability, performance, and overall quality. Feature enhancements. New versions often introduce new features, functionalities, and capabilities. Security updates. Security vulnerabilities are a common concern in software, so new versions may be released to address security flaws. Performance optimization. Over time, developers can identify ways to optimize the software's performance, making it faster, more efficient, and more responsive. New versions may include these performance enhancements. Market competition. In competitive market, software companies continuously evolve their products to stay ahead. New versions can introduce innovations that help software stay relevant and competitive. These are just a few reasons, and there could be many more reasons depending on the type of software and need. As performance testers, we should be aware of the version that we are conducting our testing. This will be also applicable to the actual software or application that we are testing it. Now let's look at the different environments that we will have in the companies. Before we look at it any further, let's explore what exactly is an environment. Basically, the environment is a collection of hardware and software tools that the team will use to build software systems. In general, every software development company will have different environments that serve a specific purpose. Additionally, separate environments provide a safe space for the respective team without affecting each other's deliverables. Let's explore some of the common environments found in different companies. Development environment. This is the environment used by developers. In this environment, they will write, modify, and test the code. Here, testing means unit testing. This environment allows developers to work freely on the software without worrying about the impact on end users. One of the most important uses of a development environment is that it allows developers to ensure various functions of the application or program work as intended before it released to users. Testing environment. The testing environment is where the testers, either functional or non-functional testers, analyze the quality of the software or application. They will identify the bugs or issues in the software and report them back to the developers. Some of the testing environments closely resemble the production environment. Based on the needs and requirements, companies will have different types of testing environments, such as SIT environment, nothing but system integration testing environment. This environment is mostly used by the functional testers to carry out different types of functional tests. And then UAT environment, nothing but user acceptance test environment, in which business users will carry out the testing. Performance testing environment, and this is the environment where the performance testers will carry out all the performance testing activities. Depending on the company's size and need, there may be some other testing environments as well. Pre-prod staging environment. A pre-prod staging environment is a replica of the production environment. The main purpose is to ensure that all new changes deployed from previous environments are working as intended before they are deployed in the production environment. Production environment. This is the environment where the end users of the software can see, experience, and interact with the software or application. Any issues in the environment may severely impact the business, so the companies will ensure that production environment is stable and reliable as much as possible. While accessing the application, if you see any issues, then those issues are occurring in the production environment. I hope you got some idea about different environments. Please feel free to mention in case anything is not clear. Now let's look at what exactly a protocol is. In a general sense, protocol is a set of rules that describes how two different entities should communicate. In other words, a group of agreed rules that determine the communication between different entities. Here, entities can be persons, systems, etc. For instance, we always follow the protocol to communicate with others in our day-to-day life. If you are communicating in English, you will follow grammar rules to communicate with others. If you are not following them, the other person might not understand anything. Let's try to understand the concept with a real-time example. Let's assume John and Mary met together after a long time. John would like to check with Mary about her weekend's plan. If John say, "Weekend doing this, you what are?" Will Mary understand anything here? I don't think she will understand anything because John did not follow the English grammar rules, isn't it? Suppose John follows the rules and says the same sentence like, "What are you doing this weekend?" This time Mary understands and will respond to something. For instance, if she is free, then she might say, "I am free, I don't have any plans." The reason for sharing this example is to explain the importance of the rules defined for communication. That is nothing but protocol. If both parties follow the protocol, then they can easily communicate. The definition of the protocol in the computing terminology is very much similar to the general sense. It is a set of rules that determine how the data is transmitted between different devices across a network to exchange information easily and safely. In general, communication will happen between the client and server. Based on the need, the client will request something from the server by following the rules that the server understands. Then the server will respond back with the required information. The available protocols can be categorized into three different types: communication protocols, management protocols, and security protocols. Let's look at communication protocols first. Communication protocols formally describes the formats and different rules for data transfer over the network. Communication protocols also handles authentication and error detections. Let's look at some of the examples of communication protocols. HTTP protocol. Here HTTP stands for Hypertext Transfer Protocol. This is one of the most popular protocols over the internet. It is designed to transfer hypertext among two or more systems. It is an application layer protocol that allows the browser and server to communicate. If you are using a web application, then behind the scenes, your browser is communicating with the server using HTTP protocol. All the rules for this protocol have been written in RFC 9112. This is an internet standard document written by the Internet Engineering Task Force team. For example, section 2 of this RFC describes the messages and its format. I'll share the document link in the description for your reference. We can also trace the request and response in the browser using the developer tools. I will also share the link in the description to learn the concept of inspecting the network traffic. The next one is TCP. TCP stands for Transmission Control Protocol. It divides any message into a series of packets that are sent from source to destination, and there it gets reassembled at the destination. These packets can be sent by devices like switches and routers to the designated targets. Next one, UDP. UDP stands for User Datagram Protocol. It works in a similar way to TCP, sending packets of data over the network. The key difference between the two is that TCP ensures a connection is made between the application and server, but UDP does not. Internet Relay Chat, also called as IRC. It is a text-based communication protocol. Software clients are used to communicate with servers and send messages to the other clients. Next one, FTP. FTP stands for File Transfer Protocol. FTP allows users to transfer files from one machine to another. There are different files it transfers, such as program files, multimedia files, text files, documents, etc. Next one, SMTP. SMTP stands for Simple Mail Transfer Protocol. It is an efficient and reliable electronic mail transfer protocol. It is a protocol that transmits email between computers and alerts users when new email arrives. Now let's look at the different types of management protocols. Management protocols help define the policies and procedures used to monitor, manage, and maintain your computer network and help communicate these needs across the network. It can be used to troubleshoot connections between the host and client devices. It provides the host connection status, availability, packet or data loss, and other related information. Let's look at some of the types of management protocol. SNMP, Simple Network Management Protocol, is used to monitor and manage network devices such as servers, workstations, routers, and switches. Network administrators can use SNMP to track network performance, discover network flaws, and resolve them. ICMP, Internet Control Message Protocol, is primarily used for diagnostic purposes. Managed device on the network can use this protocol to send error messages, providing information regarding network connectivity issues between devices. Now let's look at the security protocols. Security protocols ensure that data in transit over the network's connection stays safe and secure. These protocols determine the parameters for the protection of data from unauthorized access. By depending on encryption for data protection, security protocols guarantee that network data remains inaccessible to unauthorized devices and users. Let's look at some of its types. HTTPS. HTTPS stands for Hypertext Transfer Protocol Secure. It is a secure version of HTTP. Data sent between the browser and server are encrypted to ensure protection. SFTP. SFTP stands for Secure File Transfer Protocol. It is used to securely transfer files across a network. It is a secure version of FTP and encrypts the connection between two systems when a file is sent remotely. SSL. SSL stands for Secure Socket Layer. It is primarily used for ensuring secure internet connections and protecting sensitive data. SSL encrypts data in transit to prevent it from being read. Every performance testing tool supports a set of protocols that can be used to capture the communication between client and server. So we should familiarize ourselves with different protocols. In fact, this is one of the commonly asked questions in the interview. For instance, some interviewers will ask like this: what are the different protocols that you have worked on? Now let's look at some of the other architecture components that we generally see in the software architecture. It is important to understand their purpose. CDN. CDN stands for Content Delivery Network. A CDN is a geographically distributed group of servers that caches content close to end users. The primary purpose of a CDN is to enhance the delivery of web content such as images, videos, scripts, and others to users by reducing latency and improving load times. When a user requests content from a website, the CDN routes the request to the closest server in its network, minimizing the distance the data needs to travel and improving the overall speed and performance of the website. Akamai, Amazon CDN, Azure CDN, Cloudflare are some of the CDN providers. Proxy. A proxy is an intermediate server that acts as a gateway between the client and the server. When a user makes a request to access a resource on the internet, the request is sent to a proxy server instead of directly connecting to the target server. The proxy server then forwards the request to the target server on behalf of the client and receives the response. There are different types of proxies available, such as forward proxies, reverse proxies, etc. Firewall. A firewall is a network security device or software application that acts as a barrier between a trusted internal network and untrusted external networks such as the internet. The primary purpose of a firewall is to monitor, filter, and control incoming and outgoing traffic based on a set of predefined security rules. By doing so, firewalls help prevent unauthorized access, data breaches, and cyber attacks. Firewalls can be implemented in various ways, including as hardware appliances, software applications, or virtual appliances. Load balancer. Load balancing refers to efficiently automatically distributing incoming traffic across a group of servers. A load balancer acts as the traffic police, sitting in front of your servers and routing clients' requests across all servers capable of fulfilling those requests and ensuring that no one server is overworked. If a single server goes down, the load balancer redirects the traffic to remaining online servers. When a new server is added to the server group, the load balancer automatically starts to send the request to it. Load balancers can be implemented in various ways, including as hardware appliances, virtual appliances, or software applications. Now let's look at what exactly is a URL and its different components. URL stands for Uniform Resource Locator. It is nothing more than the address of a given unique resource on the web. A resource can be an HTML page, a CSS document, an image, etc. A URL is composed of different components. Now let's look at those components. Here is an example of URL and its different components. The first component of the URL is the scheme, which indicates the protocol that the browser must use to request the resource. Usually browser use HTTP or HTTPS protocol for communication. Just to let you know that in some scenarios, we may be seeing different schemes other than HTTP, HTTPS. The next one is domain, which is separated from the scheme by the character pattern : 2 backward slashes. The domain name is the name of the website. On the website, the resource will be requested from the web server. If you take the store as an example, where the domain name is the store name, the URL is the store address, and the website is the actual store. The next one is port. This is an optional component that specifies the port number to use when establishing a connection to the server. In other words, the port indicates the technical gate which is used to access the resources. If no port is specified, the default port associated with the protocol is used. For example, the default port for HTTP is 80 and the default port for HTTPS is 443. The next one is path to file. This is the path to the resource on the web server. Think of it as a directory in the regular file system. The next one is the resource. This is the actual resource for which the request has been sent to the web server. Along with these components, there are some other optional components available like query, anchor, etc. Do you know what happens when we type URL into the browser? So when we type URL into a web browser's address bar and hit enter, several steps happen behind the scenes. Let's discuss those steps. Firstly, URL parsing will happen. The browser parses the URL into various parts such as scheme, domain name, path, and the resource. Then the browser needs to translate this human readable domain name, in our case it is www.example.com, into an IP address that the computer can use to locate the server on the internet. This process is called DNS resolution. Here DNS stands for domain name system. The browser sends a DNS query to a DNS server to retrieve the IP address associated with the domain. Then using the IP address obtained from DNS, the browser establishes a TCP connection to the server. If a specific port is specified in the URL, the browser connects to that port, otherwise it uses the default port associated with the scheme. Then the browser sends an HTTP request to the server, including the method like get, post, the path to the resource, header such as user agent cookies, etc., and other relevant information. Then the server processes the request and constructs the HTTP response, which includes the status, code, headers, and the actual data. Finally, the browser receives the HTTP response. It then processes the received content, renders HTML, applies styles, and executes JavaScript code. It creates a visual representation of the web page in the browser's window. So that's it for this video. Thank you so much for staying till the end and supporting me. I hope you understand all the concepts in this video. In case any specific concept is not clear or requires more detailed information, please feel free to mention it in the comment section. If you are new to our channel, please consider subscribing and also like and share this video so that others will also get benefited. With this video, we have completed our module 3 concepts, and I'll see you with module 4, which is performance testing core concepts. Until then, take care, stay safe, and keep learning.